The door stud is a remarkable tool that allows a contractor or an individual to hang a door with ease. This tool turns an hour-long project with 2 people into a project that can be done in a matter of minutes with 1 person. The door stud can accommodate 3 different sizes of door. This is done by having different sizes of spacer clips, like the one seen here. Our team has been working with Stud and Assembly Systems, the company that makes the door stud, to produce a new method to create these spacer clips. Our team consists of 4 members: Shannon Onstad, Nathan Onstad, and Ryder Belgarde. And finally, Avery Jorgensen. These spacer clips are formed from a 4-foot long piece of extruded PVC cut into 4-inch sections and given a 45-degree angle on each side. Currently, Assembly Systems uses a series of 2 different chop saws to complete the cuts. This process is potentially hazardous, and currently only 1 person is able to operate it. Based off our flow diagram, we created several different concepts that we could possibly move forward with. Each of us came up with several different ideas, and we came to the decision that a combination of all our different ideas would be the most beneficial to the company. Once we decided on a design, we created a 3D model of it using Creo. As we did calculations on our design, we found that the pneumatic cylinder used would be impractically large and the blade too complicated to machine, so it was back to the drawing board. After a while, we had a design that we felt would fit all of the criteria that we needed to fulfill and would function extremely well. This design implemented 3 different punch blades, one coming down from the top to perform a length cut, and 2 on the sides to perform our 45-degree cut. Each of these punches is driven by a pneumatic cylinder triggered by an Arduino microcontroller. The long extrusions are moved towards the punch blades by a peg and belt system driven by a stepper motor controlled by the same Arduino. To verify the structural integrity of our design, the team conducted finite element analysis on both the pneumatic frame and the table assembly. In this analysis, we found that the frame held up to the forces applied, but the table did not. We added 4 supporting beams where we saw the max stress. After this, we found that the max stress was well below the yield stress of the steel. Compared to Assembly Systems' current setup, our design is much safer as it is surrounded by a layer of plexiglass shielding. Our design is also much more efficient than Assembly Systems' current setup, as any individual could come and load and extrude onto the bed and it autonomously move forward. Our machine is also very user-friendly, as any individual can come up and use it with little to no training, because it is almost entirely automated. For our completed design, we would like to thank our mentor, Dr. Tangpong, Rob Saylor for his help in analyzing our design, and all the other professors who have helped us along our way.